What's up, what's up? I hope y'all are as excited about learning math as I am about teaching you. Yes? No? Okay, well, welcome back to my whiteboard. Okay, so now we're going to look at solving equations with variables on both sides. So looking at example 1 and 2 here, the first one, it says solve 10 minus 4x equals negative 9x. So if you notice, we're solving for x, but we have two of them. Normally we would just combine them, but they're on opposite sides of the equal sign. So in order to get them together, we're going to have to move one, and you do the opposite to it, just like if we were getting rid of a number, okay? So I have 4x and 9x. Well, if you notice, negative 9x is the only thing on this side of the equal sign. So I'm not going to move it, because if I move it to the other side, I've canceled everything out from over here. And that doesn't make sense. It's no longer equals anything. So we have to move this 4x over to this side. You always want to get your x's together before your other numbers. Excuse me. So since we have minus 4x, I'm not going to divide because that would separate the 4 from the x. We want to move the whole thing, so we look out front. It's minus 4x, so you'll do the opposite and add 4x to both sides of your equation. All right, so when we bring that down, I'll look here. So right here, they've added 4x. So we bring this 10 down, negative 4x plus 4x cancels. We have an equal sign, and then negative 9x plus 4x is negative 5x. So this is now our new equation. 10 equals negative 5x. So we still have to solve for x. These two are being multiplied, so we would do the opposite and divide by negative 5 in order to get rid of it from both sides. So I have x equals 10 divided by negative 5 is negative 2. X equals negative 2. And just like before, you can go back and plug that in for x, and you can see that it comes out to 18 equals 18. So when we have multiple x's, we first have to get them together. So here's another example. This one looks complicated because we've got parentheses and fractions going on, but just take it step by step. So the first thing we have to do on these is distribute. So we have to distribute this 3 into these parentheses. So 3 times 3x is 9x. 3 times negative 4 is negative 12. So I have 9x minus 12 on this side now. Then on the other side, we have to distribute this 1/4 into everything in parentheses. So 1/4 times 32x, that just means what's a fourth of 32, or basically 32 divided by 4. So that comes out to 8x plus, and then 1/4 times 56 comes out to exactly 14. So this is our new equation right here. It looks much easier to use. So we have to get our x's together first. So we've got to, they show getting these numbers together, but I highly recommend always getting your x's together first. So I'm going to subtract this 8x over to both sides. 9 minus 8 is 1, so I have x minus 12 equals 14. So now all we do is add 12 to both sides, and we get x equals 26. So I want you to try all 3 of these problems down here at the bottom. You'll pause the video, and then I'll work them out for you. So on these first problems, 1, 2, and 3, you're trying to get your variables together first. So on negative 2x equals 3x plus 10, okay, we've got to get our x's together. They're on opposite sides of the equal sign, so you're going to have to do the opposite to move one of them across. If I move this one, I cancel everything out from this side of the equal sign, and you don't want to do that because you've got to have something to keep your equation balanced. So that means on this particular problem, we want to move this 3x. So since it's a positive 3x, we wouldn't divide because that would get rid of the 3 only and not the x. It would split them apart. We want to move the whole thing. So since it's a positive number, that means there's like a little imaginary plus sign. So we would subtract 3x from both sides. Negative 2 minus 3 more is negative 5x. That x hasn't gone anywhere. We haven't gotten rid of it. I have an equal sign. This canceled, and I'm left with positive 10. I now have negative 5x equals 10. So again, we're solving for x. We haven't done that yet. Now, I want to split these apart. Keep the x here, but get rid of this negative 5. So you look between them. They're being multiplied, so the opposite of that is to divide both sides by negative 5. Negative 5 divided by negative 5 is 1x. 10 divided by negative 5 is negative 2. Okay, number 2. This one has a fraction, so it may have taken you a little longer, but 1/2 is the best fraction because it's easy to multiply with. So we have 1/2 times 6h minus 4 equals negative 5h plus 1. So we have to distribute this 1/2 in here because I can't do anything in those parentheses right now. Half of 6 is 3h minus half of 4 is 2. And then on this side, negative 5h plus 1. So I have to get my h's together. Okay, on this one, it doesn't necessarily matter which one you move, because if I move that 3h, I still have a number there, or if I move the 5, I still have a number here. So you get to choose on this one. I'm going to move this one. Since it's the negative 5, I'm going to add 5h to the other side. 3 plus 5 is 8h minus 2. This cancels, and we're left with 1. I now am solving for h. Here's the equal sign. So I've got to get rid of this 8 and 2. You get rid of the one that's by itself first. It's being subtracted. So we do the opposite and add. I have 8h equals 3. Last thing we do is then divide. So h, and I would just keep it 3 over 8. Okay, last one, number 3. We have negative 3/4 times 8n plus 12 equals 3 times n minus 3. So we got to get rid of all these parentheses. So on this, I would take it as 8 over 1. 3 times 8 is 24. 24 divided by 4 is 6. So that is negative 6n. Then we have 3 over 4 with 12 over 1. I would cross cancel on that one with 4 and 12. But if we were to do it like this, 3 times 12 is 36 over 4. 36 divided by 4. I'm going to have to get a calculator. I can't even remember that. I just want to double check myself. That's what I thought. 9. Duh. I was having a blonde moment. Okay. So that is minus 9 equals, and I'm going to go ahead and do this side as well. 3 times n is 3n minus 3 times 3 is 9. So I have n's on both sides of the equal sign that I have to get together, and I have other numbers. So I'm going to move this one. You get to choose. So since it is a negative 6, I'm going to add 6n to the other side. I'm left with negative 9 equals 3 plus 6 is 9n minus 9. Okay, we're solving for n. Lots of 9's up here. I've got to get rid of this 9 and this one. You get rid of the one that's by itself first. Remember, it's PEMDAS backwards. You start with adding or subtracting, then multiplying or dividing, because you're doing the opposite on everything. So it's subtracted, so we add. Negative 9 plus 9 is 0. Negative 9 plus 9 is 0. Well, anything divided, or 0, divided by anything is just 0.
Okay, now we're going to look at example 3. On this one we have A and B. This one we're going to determine if it's true or false. You'll know when it's this type of problem whenever you go to solve it and something weird happens. So looking at A, we've got to distribute this 3 into these parentheses because we have 2 x's going on. So to solve for it, we first have to get them together. So when we distribute that 3, it goes to everything. 3 times 5x is 15x, plus 3 times 2 is 6. So our new equation is 15x plus 6 equals 15x. So remember I told you
you want to get your variables together first before getting rid of other numbers. And these are the exact reason why we have to do this. It worked out okay on that other problem, but these problems are why you should do this first. So if we look, we're going to get our x's together. When you're trying to determine which one to move, sometimes it doesn't matter, but this one, if I move this 15x, I get rid of everything from this side, and you don't want to do that. So you need to move this one. So since it's a positive number, remember that's like a little imaginary plus sign. So we do the opposite and subtract 15x. We're not going to divide because that just gets rid of the 15. We want to move the 15 and the x. So we subtract it from both sides. And if you notice, 15 minus 15 is 0. I'm left with 6 equals, and 15 minus 15 is 0. So our letters canceled, and we just have 6 equals 0. And we can obviously see that that is false. So that is never true. So this equation has no solution. So you would write no solution, or this is the symbol for no solution, a 0 with like a diagonal line through it. No solution. Okay, so now let's look at example B. It's another type of example using the true or false. So again, we're going to have to distribute this negative 2 into the parentheses. So negative 2 times 4y is negative 8y. Then we have negative 2 times 1, so I have minus 2. If you put plus and negative here, that's the same thing as minus. So negative 8y minus 2 equals negative 8y minus 2. This example right here is why you have to get your variables together first. So on this one, I can move this 8 and there'd be a 2 left, or I can move this 8 and there'd be a 2 left. So this one, it doesn't matter which variable you move. So we're going to move this one. Since it is minus, we are going to do the opposite and add 8y to both sides. That cancels, and I have negative 2 equals. This also cancels, and I have negative 2. So my variables canceled out again. And since I have negative 2 equals negative 2, well, that's true. No matter what y is, this will always be true. So this equation is identified as what's called infinitely many solutions. There's no easy way to write that. You just got to write infinitely many, okay? That would be our answer because it means it doesn't matter what y is. Y could be 10,000. It's going to cancel, and negative 2 will always equal negative 2. So basically, when you're working out these problems, if your variables cancel out, then it becomes kind of a true-false on whether or not it has a solution, infinitely many, or no solution. So what I want you to do now is you're going to go ahead and try all 4 of the problems at the bottom, 4, 5, 6, and 7. I know it'll take a little bit of time. That's okay. Pause the video and work those out because those are going to be the last ones we look at, and then I'll go over them with you.
For 4, first thing we have to do is distribute. So I have 4 minus 4p equals negative 4p plus 4. So I have a p on both sides of my equal sign that I want to get together. Since there's other numbers, it doesn't matter which one you move. I'm going to move this one. I have a 4. That cancels. This one also cancels. 4 equals 4. That is true. So the answer is infinitely many. Means no matter what p is, no matter what we plug in for p, it's going to cancel. So 4 will always equal 4. That will never change. That's always true. So now on to 5. This one has a fraction that we've got to multiply in. Well, 5 over 6 times 6 over 1, those 6's cancel. So that is just 5m. 5 over 6 minus 10, or excuse me, times 10. 5 times 10 is 50, divided by 6. Let's just keep that. Let me double check that, but I may just leave that as a fraction for now. Yeah, it's a mixed number, so for now, I'm going to leave that as 50 over 6. And then I have 6m minus m. So this one has 3 different m's. These are on the same side of the equal sign, so I can just do what's between them. 6m minus 1m is 5m. Okay, then I have to move this one because there's nothing else on that side. I'm moving the whole thing, trying to get my letters together, so I have to do the opposite. I'm left with negative 50 over 6 equals 0. That is obviously not true, so that is no solution. Okay, number 6. 10k plus 7 equals negative 3 minus 10k. I'm going to move this one first. Doesn't matter which one on this one because we have other numbers on either side. I have to do the opposite because I'm moving it across the equal sign. $10 plus 10 is 20k. If you accidentally cross that off, don't let it trick you. Okay, so 20k plus 7 equals negative 3 minus 7. Negative 3 minus 7 more is negative 10. And then I would divide by 20. And I get negative 1/2. So that one is technically considered one solution because we had infinitely many solutions, which means it could be anything. No solution, where it cancels and it's not true. Then one solution, and our solution is k equals negative 1/2. Okay, now let's look at the last one, 7. We have a lot of distributing to do on this one on both sides. 3 times 2a is 6a minus 3 times 2 is 6 equals 2 times 3a is 6a minus 2 times 3 is 6. A lot of 6's on there. Okay, so let's get our variables together. They're on opposite sides of the equal sign, so I have to do the opposite to get them together. 6 minus 6 cancels. Negative 6 equals 6 will always be true. So that one is infinitely many.